In this chapter, we are going to talk about the structure and properties of ionic and covalent compounds. When we talk about this, it's important to understand chemical bonds. So when we say chemical bonds, what we're referring to here is the force of attraction between any two atoms in a compound. Okay. Now, there are three basic types of bonds. The first type of bond is that we're going to talk about is ionic. The second type is covalent. And then the third type, which we won't talk about too terribly much, is metallic. I like this image. It shows you kind of representative examples of all three of the bonds. And so what you see here is salt going into water. And the salt is an example of ionic bonding, where you have ions that are held together by opposite charges, which we talk a lot about as being electrostatic interactions. And then the water is an example of a covalent bond, and these are held together by sharing electrons. And then the metallic bond is the spoon, and these are held together by a sea of electrons surrounding the nuclei. And the electrons, of course, move between those atoms. So let's go and kind of dive into different types of chemical bonding. One of the people to describe chemical bonding was a gentleman by the name of Gilbert Lewis, and he proposed, and there's a picture of him here, but he proposed that atoms form chemical bonds by sharing electrons to acquire an octet. Now, this falls into the octet rule, which we talked about in a previous screencast, but I just want to remind you about the octet rule. So when we talk about the octet rule, it's just a brief review that atoms tend to gain, lose, or share electrons to obtain a set of 8 valence electrons. So they want to be surrounded by 8 electrons in that outermost shell. And so to help us visualize this, he came up with Lewis symbols. And these a lot of times are called Lewis dot structures. And so when we talk about this, this is a chemical symbol for an atom surrounded by one or more dots, and those dots represent valence electrons. So it's the chemical symbol for an atom surrounded by one or more dots representing valence electrons. So when we look at this, for example, carbon is a really good example. When we've talked about valence electrons in a previous screencast, and we're going to review those in this screencast. But if you look, carbon is in group 14 or group 4, depending on what periodic table you look at. And you would put the dots around carbon like this. And so generally, when you put the dots around, the first 4 electrons are unpaired, and they go to the top, sides, and bottoms. Then if you were to look at something like chlorine, which has 7 valence electrons, you would pair those up around and then leave one unpaired. So let's look at some examples of this. Again, the unpaired dots are the valence electrons. And these are the electrons that are involved in bonding. So a lot of time this is referred to as the element's bonding capacity. So for example, if carbon has 4 unpaired electrons here, then it's got 4 spaces to form a bond. When we look at chlorine, Here, chlorine has one available space, and so it's got one space to form one bond. So carbon tends to form 4 bonds, and chlorine tends to form 1 bond. And that's what we mean by bonding capacity. Now, this is a complete review, so I just want to remind you that we can figure out the valence electrons, or the dots that we're going to use in the Lewis dot structures, by looking at the group number of the main group elements. And so to figure out the valence electrons of the main group elements, you just need to look at the group number. Right? And so group 1 has 1, group 2 has 2. Some older periodic tables will say this is 3A. Newer periodic tables will say 13. Just drop the 1 here and it'll tell you the number of valence electrons. So 3, 4, 5, 6, 7, and then 8. There's some notable exceptions. Helium and hydrogen just need 2. And so those are those kind of notable exceptions to this. So not every element follows the octet rule, but many of them do. Okay. So let's look at how ionic compounds form. Okay. So when we talk about ionic compounds, right, these consist of charged atoms or particles, which we call ions. Okay. And these are formed by the transfer of electrons between atoms. Okay, so I love to look at it like this. I love this graphic because basically it shows, one atom proposing to another and saying, hey, look, I want to give you an electron, which somehow works, right? When we look here at sodium, sodium has one valence electron. It gives that valence electron to chlorine. Chlorine now has a full octet. Sodium also has a full octet because it goes back to a lower shell. And so both sodium and chlorine are happy with charges. And because these are opposite charges, just like magnets, they attract each other and form what we consider and call a crystal lattice here. So I want to remind you of a few things. These ions are held together by electrostatic forces. That's just a way to say, look, one's got a positive charge, one has a negative charge. Just like magnets, they're attracted to each other. I want to refresh your memory. We talked about this before, but we're going to refer to this a lot more in this screencast. So this is just a brief review. Cations are ions with a positive charge. A really good way to remember this is cats have paws, right? And so cats and paws, and it's positive. And then we also have anions, right? And these are ions with a negative charge. And I don't have a fun thing to remember that. I'm still working on it. But these are some really important vocabulary words for us to remember what they mean, because we're going to continue to use them. Now, as a general rule, metals tend to lose electrons to form positively charged cations. So our general rule is that metals lose electrons. Now, the reason they do this is because they have a really low ionization energy. So it's really easy to lose an electron. So we have a low ionization energy. And so as a reminder, this can be shown as sodium here, right? Becoming sodium plus, and then the electron it's lost, okay? So ionization energy is just the energy required to lose an electron. We talked about that in a previous screencast. Now, nonmetals tend to gain electrons. So these have a really high electron affinity, so it's easy to gain an electron. So nonmetals have a high electron affinity, so it's easy to gain electrons. And so this is shown a lot of times as our friendly Cl here in our Lewis dot structure plus an electron goes to Cl here, and we have a full octet, but we also have a negative charge. So notice these charges here are shown as superscripts. You'll want to keep them as superscripts. One of the things that you'll hear quite a lot is these form a crystal lattice. The simplest whole number ratio of cations to anions that yields a neutral compound is a lot of times called a formula unit. So when we're referring to ionic compounds, like for example sodium chloride, even though it forms a lattice like this where there's a repeating pattern, if we're talking about just one kind of unit where the charges cancel, then we call that a formula unit. So you're going to hear that vocabulary quite a bit. So I just wanted to let you know what we're talking about there. Now let's talk about covalent compounds and covalent bonds. Sometimes these are called molecular compounds, and these are just atoms held together in molecules by covalent bonds. Okay. Covalent bonds are bonds created between, let me spell out between here instead of using a shorthand, between two atoms by sharing one or more pairs of electrons, right? And so I again love this kind of comic or graphic. We see two atoms and it's like they're sharing a meal of electrons, right? But they share an electron to form a bond. A good example of this, I want to say one more thing. These guys are nonmetals, right? So these covalent bonds, they form between atoms with similar tendencies to gain or lose electrons. And so those are our nonmetals. As a matter of fact, when we look at this, a really good example is hydrogen. So hydrogen has one valence electron. And so when it gets close to another hydrogen with one valence electron, these form a bond where they're sharing those two electrons. And a lot of times we show this as a single bond like that. And that single bond says, hey, look, we are sharing two electrons. You can also have double bonds like here. So we have CO2 here. There's a double bond that forms between the carbon and oxygen, and that's sharing 4 electrons. And then there's a triple bond here, and that's sharing 6 electrons. So those are we in this class we're only going to have single, double, and triple bonds. So those are going to be some examples of covalent bonding here. I want to also point out that you have some diatomic elements And just as a reminder, di means two. And what these are these naturally occur as two atoms that are bound by covalent bonds. There are 7 of them, and with the exception of hydrogen, they make a 7 on the periodic table. And so that's how I remember them. And so those are F2, Cl2, Br2, and I2. Now, it's really important to commit these to memory or make a note on your periodic table because they will come up again. They're tricky, so they'll kind of appear when you least expect it. So you'll want to just make a note on your periodic table when you get your periodic table for the exam. Every time, my suggestion is to note the atoms that are diatomic because that tends to help you. If you have any questions, feel free to pop by my office. I'm happy to help.